Hi everyone, so today I'll be going through the 2019 for the Maths Exam 1 of the Networks and Decision Mathematics section. So question 1, in the graph shown above, the sum of the degrees of the vertices is, so you should note that the sum of the degrees of the vertices is equal to 2 times the number of edges. So we'll just count the number of edges, so 1, 2, 3, 4, 5, 6. So there are 6 edges, so the sum of the degrees of the vertices is equal to 2 times 6 edges, which is 12, so therefore E is the correct answer. Question 2, consider the graph below. The minimum number of extra edges that are required so that an Eulerian circuit is possible in this graph. So you should know that an Eulerian circuit always has, the graph of a Eulerian circuit always has even vertices. So if you look at this graph over here, we have an odd vertex here, even vertex here, or odd vertex, even vertex, and 1, 2, 3, 4, 5 odd vertices. So basically we want all the degrees of the vertices to have an even degree. So to do this, we basically add edges between the vertices that have odd degrees. So if we add an extra edge over here, so basically that would make this vertex to have a degree of 6, and this vertex would now have a degree of 4. And now we could connect the an edge between this vertex and this vertex. So that means this vertex, that vertex would have a degree of 4, and this vertex would also have a degree of 4. So now all of the vertices have an even degree. So therefore an Eulerian circuit is possible, and we did that with a minimum of 2 edges. As you can see, we added 2 edges to make this possible, and that is the minimum number of edges because we connected it between the 2 odd vertices for each one. So we connected it between this odd vertex and this odd vertex and this odd vertex and this odd vertex. So therefore 2 edges was the minimum number of edges, so that all of the vertices would have an even degree. So therefore C is the correct answer. Question 3. The flow of water through a series of pipes is shown in the network below. The number of edges show the maximum flow through each pipe in liters per minute. The capacity of cut Q in liters per minute is. So to find the capacity of cut Q, we add all of the numbers on the edges through which cut Q passes through. So we'd add 5 plus 6, and we wouldn't add 3 because I've noted over here that you don't count backward arrows, and you'd also add this 3 over here. So if you do 5 plus 6 plus 3, that will give you 14. So therefore the capacity of cut Q is 14 liters per minute. So therefore C is the correct answer. Question 4. 2 graphs labeled graph 1 and graph 2 are shown below. Which one of the following statements is not true? Graph 1 and graph 2 are isomorphic. So to find whether graphs are isomorphic, basically you just calculate the degrees of the vertices. But in this case, we can already see that this graph has 1, 2, 3, 4 vertices, and this graph only has 1, 2, 3, 4, 5 vertices. Isomorphic basically means they're the same graph, just drawn differently. But as we can see here, they're obviously different graphs because we can see that this graph over here has 5 vertices, whereas this one has 4. So therefore, they're obviously different ones. So therefore, this statement is not true. I'll go through the other options. Graph 1 has 5 edges. 1, 2, 3, 4, 5. So that's correct. And graph 2 has 6 edges. 1, 2, 3, 4, 5, 6. Therefore, that statement is correct. It is true. Both graph 1 and graph 2 are connected graphs. Connected graphs just mean that each vertex can be reached via another edge. As we can see, all of the vertices can be reached to other. You can get from one vertex to any other vertex by going through other vertices, and we can see that's the same with graph 2. So therefore, that's a true statement. Both graph 1 and graph 2 have 3 faces each. So count the number of faces: 1, 2, 3. So graph 1 has 3 faces. Graph 2 has 1, 2, 3 faces. So therefore, that's a true statement. Neither graph 1 nor graph 2 are complete graphs. That is also a true statement because complete graphs means that each vertex is directly connected to all other vertices. However, that's not the case in graph 1 and graph 2. So therefore, that leaves us with A. Question 5. The following diagram shows the distance in meters along a series of cables connecting a main server to 7 points A to G in a computer network. The minimum length of cable in meters required to ensure that each of the 7 points is connected to the main server directly or via another points is. So basically the question is just asking us to find the minimum spanning tree for this graph over here. So if we do that, we start up to find the minimum spanning tree, we just start off with the smallest edge. So we can start off with the smallest edge, 15 over here. So 15 over here. And we look for the next smallest edge that is connected to that edge. So we can see the next smallest one is 28. And after 28, we can look around for the next smallest edge. So either 35, 30, 33, or 36. So the next smallest one is 30. And then if you look from that edge to other edges, we know that we have 40, we have 35, we have 32, 33, and 36 over here. 32 is the smallest one, so therefore highlight the 32, the edge between F and G. So the next smallest edge would be 35, as we can see over here. And the next smallest edge is also 35 over here. So we'll highlight both of those. And then the next smallest edge to connect B finally is 28. So therefore, if you add that up on your calculator, you'll get the minimum length of cable. So 15 plus 28 plus 32. So if you add that up on your calculator, you'll get 203 meters. So therefore B is the correct answer. Question 6, the map below shows all road connections between 5 towns, P, Q, R, S, and T. The road connections could be represented by the adjacency matrix. So to do this question, I'll just go with the process of elimination rather than trying to construct like the whole matrix. So the first distinct difference that we can see between these matrices is that from P to P, so some have 1 and others have 0. So we should determine how many pathways are there from P to P. Is there any pathways or is there actually 1? So if we can look at here, we're trying to get from P to P. So we can see that if you follow along this route, we can get from P to P. And there's only one way to get, there's only one loop at P. So therefore, one from P to P would be correct. So we can get rid of the matrices that show 0. And now we're left with A, B, or E. And if you look at this from P to Q, you can see that some have 2 and some have 3 and one has 3. So that means we're looking for to determine whether the graph has 3 ways to get from P to Q or 2 ways to get from P to Q. So if we try that out, P to Q, this could be one path, this could be another path, and this could be the final path to get from P to Q. So there's 3 ways to get from P to Q. So therefore you get rid of option B and option E as they only show 2 ways from P to Q. And that leaves us with A. So therefore A is the correct answer. Question 7, a project involves 9 activities A to I. The immediate predecessors of each activity is shown in the table below. The directed network for this project will require a dummy activity. The dummy activity will be drawn from the end of. So to do this question, you actually need to draw out the graph. So we know that A the start would be here, and A would come from that start because it has no immediate predecessors. And then B comes from A, so we'll just draw it like that. And we also know C comes from A, C comes from A, so C is coming from A. And D comes from B, so D comes from B, D comes from B, and E comes from B and C. So if E comes from B and C, then that would mean we would need a dummy activity over here to connect to E. This is because we can't have 2 edges from one vertex going to another vertex. And so therefore that would require us to use a dummy activity. So therefore B is the correct answer, as the dummy activity comes from the end of activity B and goes to the start of activity E over here. So therefore B is the correct answer. Question 8. The directed network below shows a sequence of activities A to S that is required to complete a manufacturing process. The time taken to complete each activity in hours is also shown. The number of activities that have a float time of 10 hours is... So to do this question, we need to complete the critical path analysis. So to do this, I'll go through it right now. Just put boxes on each edge to start off with, and then I'll go through the process. So once you've done that, basically we pick the smallest number going forward, and we start off with 0 over here, so 5. Sorry, we pick the largest number going forward, so 5 plus 4 is 9, 5 plus 7 is 12, and 12 plus 4 is 16, and then 5 plus 1 is 6, 6 plus 3 is 9, largest number 16, so that should say 16, 16 plus 5 is 21, 6 plus 8 is 14, 9 plus 3 is 12, 12 goes in here, 12 plus 6 is 18, largest number, 18 goes in the box, 18 plus 5 is 23, 18 plus 6 is 24, largest number goes in the box, 24, 24 plus 7 is 31, 12 plus 7 is that is 19, 19 goes in the box, 19 plus 2 is 21, largest number from these three edges is 31, so 31 goes in the box, 31 plus 8 is 39, 39 goes in the box, 39 plus 1 is 40, 31 plus 11 is 42, largest number goes in the box, so 42 goes in the box, 42 plus 9 is 51, so therefore that's the shortest time to complete the project, and 51. So now we're backtracking, which involves picking the smallest number when you're going back. So 51 minus 9 is 42. 42 minus 1 is 41. 41 minus 8 is 37. 42 minus 11 is 31. 37 minus 2 is 35. Sorry, should be 30. 31 minus 2 is 29. 31 minus 5 is 31 minus 5 is 26. 31 minus 7 is 24. 24 minus 6 over here gives us 24 minus 6 gives us 18. So that is wrong because 26 should have gone over here, and we wait till we find what the smallest number is. So 18 is here. 18 minus 6 is 12. And 29 over here minus 7 is 22. So therefore, the smallest number is 12, goes in the box. 12 minus 3 over here is 9. 9 minus 4 over here is 5. Let's come back over here, 18. 18 minus 8 is 10. 24 minus 5 is 19. 19 minus 3 is 16. Smallest number goes in the box, which is 10. 10 minus 1 is 10 minus 1 is 9. 19 minus 4 is 15. 15 minus 7 is 8. Smallest number is 5. 5 minus 5 is 0, so therefore our critical path is where all the numbers are the same on the left and right side of the box, which we can conclude over here. And so basically those activities have a float time of 0, but we want to find 0 hours, but we want to find activities that have a float time of 10 hours. So in order to do this, we'll just look for activities that have a difference of 10 between the left hand early start time and latest start time. So early start time is the left number on the left side of the box, and latest start time is the number on the right side of the box. And float time is equal to latest start time minus earliest start time. So we're going to look for activities that have a float time of 10. So we'll start off from the right side. This activity has a float time of, so activity R, we look at the left side box, there's a float time of 2, so that's not the right answer. Activity P has a float time of 37 minus 31, which is 6. And activity Q has a float time of 0, so none of those. And if we go back over here, we can see that the float time of activity M is 26 minus 18, which is 8, so not a float time of 10. 29 minus 19, 29 latest start time minus early start time is 10, so therefore N has a latest start time, or has a float time of 10, so that's one activity we have so far. And if we look at activity I, 22, which is the latest start time, minus 12 early start time, that gives us also a float time of 10, so therefore that's another activity. So we'll just put that in box I. And we can see over here, I think the last one is G, which has a float time of 10 because we can see the latest start time 16 minus the earliest start time 6 is 10. So therefore activity G has a float time of 10 hours. So therefore, looks like those are the only ones. Those are the only ones we can have. They have a float time of 10 hours. So therefore there's 3 activities, 1, 2, 3, N, I, and G, which have a float time of 10 hours. So therefore D is the correct answer.